All right, solving question 9. A protactinium generator is a device that can produce samples of an isotope called protactinium-234. A teacher investigates the activity of protactinium-234 using the apparatus shown in the photograph. So basically ওরা হচ্ছে কি করতেছে এই protactinium-234 এর activity measure করতেছে. What is activity, by the way? Activity is the amount of or measure of how radioactive a source is, right? So activity কে আমরা কি লিখতে পারি? Activity কে আমরা লিখতে পারি যে how many or number of nuclear decays that are happening per second, right? তাহলে decays happening per second. This is activity. So activity of protactinium 234 is being observed or is being done using this apparatus in the picture where we have a counter and we have a radiation detector and we have this protactinium generator. Okay, so the teacher uses a suitable detector to detect the radiation emitted from the protactinium-234. Give the suitable name of the radiation detector. What are the radiation detectors? It's always the same. It's Geiger-Müller tube. Geiger-Müller tube. Give 2 safety precautions to minimize the risk of harm to the teacher from the radiation emitted by the protactinium generator. আচ্ছা, যে কোনো type of radiation আসলে আমরা there are like certain protective measures that we have to maintain, of course, right? So ওরা যদি এখানে দুইটা লিখতে বলছে, I will give 5 so that you memorize all of them. What if you get a broad question on this? You can. তো কি কি করতে পারি আমরা রেডিয়েশন অবভিয়াসলি আমরা জানি যে রেডিয়েশনস আর আয়নাইজিং দে ক্যান কজ ড্যামেজ অর হার্ম টু আওয়ার বডিজ, রাইট? সো আমরা কি করবো সবসময় একটা সেফ ডিস্টেন্স মেনটেন করবো ফ্রম দ্য রেডিও অ্যাক্টিভ সোর্স, ওটার কাছাকাছি যে দাঁড়াবো না। অ্যান্ড আমরা ওইটা অল টাইম যদি ওপেন রাখি, ইফ উই মেক আস if we expose ourselves to the source for a longer time, then there's the possibility of harming us increases, right? So we will minimize the time of exposure to the source. How can we do that? আমাদের যখন লাগবে, we will only take it out of a metal box at that time. Other than that, as soon as we are done with our thing, we will put the source back into a metal box. So why a metal box? Metal box will absorb the radiation as much as possible. It will not let it come to us, right? যতটা minimize করা possible. And then আমরা যখন আমরা ল্যাবরেটরিতে আমাদের এক্সপেরিমেন্ট করতেছি, we will make sure that we are not pointing the radioactive source directly to any of the other students or any of the teachers. And যখনই we are using any or handling any of the source, we will make sure that we do that with a tongue and we wear gloves at all times. We do not do it with a bare hand. All right. Other than that, আমরা shielding use করব between the teacher and the source or the student and the source. Whoever is doing the experiment, there will be a shielding between the teacher and the source, which minimizes exposure to the source. So I'm writing 5 points here. But for this particular question, you only need 2 points. So this can be 1 point, this can be another point, this is another point, and these are extra points. This, and this. These are extra. Okay. Next. Protactinium-234 decays with a half-life of 70 seconds. The initial count rate is 840 counts per second. Calculate the expected count rate after 140 seconds. Okay. তো আমার 70 সেকেন্ডসে একটা হাফ লাইফ হচ্ছে, তাহলে 140 সেকেন্ডসে কয়টা হবে? ফার্স্ট অফ অল আমাদের এটা বের করতে হবে। সো ইন 70 সেকেন্ডস, in 70 seconds, 1/2 life. So I have no clue what is wrong with my pen. তাহলে 1 সেকেন্ডে, hold on a second. The pen doesn't malfunction again. So in 1 second, we will have how many? We will have less number of half-life. So it will be 1/70 half-life. We are basically doing unitary method. So in 140 seconds, We will have 1/70 into 140 half-lives, which is equal to 2 half-life, right? Which means, what does half-life mean? The amount of decay that is happening, like half of the decay that is happening, right? তাহলে 840 will decay twice. At first, it will decay, 840 will decay, and 840 divided by 2 is equals to 420, and then it will decay again because we have two half-lives. So 420 divided by 2 is equals to 210 pounds per second. So this will be 210. Next, they're saying the activity of an isotope is the total amount of radiation emitted each second. The teacher estimates that only 5% of the total emitted is detected by the radiation detector. Estimate the activity of the isotope when the count rate is 840 counts per second. Okay. Basically, a 840 counts per second a 5% of the total. Like whatever the radiation was being produced, এর মধ্যে থেকে the teacher is estimating only 5%. ওই 5% টিচার কতটুকু এস্টিমেট করছিল, এই যে এখানেও বলছিল 840 কাউন্টস পার সেকেন্ড, এখানেও বলে দিছে 840 কাউন্টস পার সেকেন্ড। সো হচ্ছিল তো 100%, এর মধ্যে থেকে টিচার এস্টিমেট করছে 5%, which is this much. You are asked to find 100% of the activity. তাহলে if 5% gives us 840 counts per second, basic unitary method, 1% আমাদেরকে কত দিবে? কম দিবে আরো, তাহলে ডিভাইড করবো, রাইট? কাউন্টস পার সেকেন্ড। And 100% তাহলে কত দিবে? Of course আরো বেশি দিবে, so we will multiply by 100 and let's see what the answer comes. 840 divided by 5 into 100, it comes 16800. And what is the unit for activity? It's becquerel BQ. 16800. I hope you understood this one.